probability. Probability was a topic which explained this, that how we can find out the chances of something. And when we talk about probability, probability can be assigned to any event. For example, if you want to find out a particular availability of microbiota in the human gut, you can do that. There could be a probability that can be assigned to that. You can talk about a particular kind of fungi existing in a lake, water lake, and still you can assign a probability to that. We can assign probability to any kind of event that is random, and most of the things in life are random. If something is not random, we usually don't need to do research on that. For example, we don't need to do research on pi, because pi has a constant value, is a mathematical term, and there are constant values for that. Again, we conduct research on things that have randomness in them, and randomization is one particular way that we use the research studies. For example, all the experiments that we perform in laboratories, they have random results coming out. That's why we are always curious about those results, and we can assign probabilities to those research results. Now, if we talk about the type of probabilities, there can be multiple types of probability, but two main types are discrete and continuous probabilities. And by now you can understand why we call them discrete and continuous probability. The reason behind that is because they can be expressed in a particular format. Discrete probability is a probability that can only be expressed in the form of complete numbers, whole numbers. But on the other hand, continuous probability is a probability that can be expressed into any rational numbers, such as fractions and negative numbers. Those kind of values can be assigned. So let's get on with the chapter. The first chapter that we talk about today would be about discrete probability distributions. And when we talk about distribution, you already are familiar with one kind of distribution, and that is called frequency distribution. As you remember, in the second chapter, you prepared a frequency distribution. And you know, frequency distribution was prepared in the form of a table. And in the very first column, you put the categories or classes, and in the subsequent column, you put frequency. So when you have classes or categories, and in front of them you put the frequency that happened into a particular trial or experiment, we call it a frequency distribution. And very similarly, when you make a table in which the column has categories or classes, and the subsequent column has the probabilities that are assigned to those classes, we call it a probability distribution. So to formally introduce this probability distribution, I would first explain that what is a random variable. Random variable is anything which can be assigned a chance. For example, what is the chance of raining today? What is the chance that how many number of car accidents would happen in the country? What is the chance how many people would get interaction with COVID-19? So all these events can be assigned some chances. So they have their probability, and hence we call them random events. And the variables that we study in these events are called random variables. So a man's age, a man's particular disease, a man's particular action is random, and that can be assigned a probability. Now, when it is discrete, which means that it can be expressed in complete numbers like 0, 1, 2, 3, 4, 5. These are complete numbers. They don't have any decimal places, or they cannot be expressed in fractions. We call these random discrete events. And the probability of these random discrete events is discrete probability. And on the other hand, there are other variables that are continuous variables. Continuous variables don't have complete numbers only involved in them. They also have the fractions, for example, decimal places, as well as the fractions that we put in the mathematical form. They're also a part of the continuous variables, the results. Okay, let me give you some examples. Decide if the random variable x is discrete or continuous. The distance your car travel on a tank of gas. For example, if you have filled the tank of your car and you're driving it, and you want to know how many kilometers the car is going to drive, it can be expressed in the form of decimals. So your car can travel up to 20.5 kilometers. Your car can travel up to 1.5 kilometers. Your car can travel to any number, any possible number. So that particular variable can be expressed into a continuous form. It can have decimal values. So we will say that this is a continuous variable. So cars travel denoted in the form of kilometers is basically a continuous variable. Next, for example, a number of students in a statistics class. I cannot say that there are 20.5 students or 16.5 students in my class. You can only say there are either 16 students or 17 students. So when we talk about a particular whole number, we are talking about discrete variables. So number of students in a class is discrete variable. Okay, so I will try to speak a little slower. All right. So continuous and discrete variable has a difference in them, that continuous variables are the variables that can be expressed in the form of decimals, whereas the discrete variables are the variables that can be expressed in the form of whole numbers. Now, what about a probability distribution? As I told you, that probability distribution is nothing but a table that expresses the probability assigned to certain events. And again, the rule of probability again is applicable here, where the probability exists between 1 and 0. No event can have probability less than 0 and more than 1, which actually means that the probability that we can assign to any particular event can be between 0 and 100%, not more than that and not less than that. 0 means there is no chance of that particular event happening, and 1 means that we are completely sure, there is no doubt that the event won't happen. Okay. So some of the probabilities in a particular event would always